DDR, known today as DDR1, was released in 2000 and was the first memory generation able to transfer data twice during a single clock cycle. For desktop systems, DDR1 modules use 184 pins, while laptop modules use 200 pins. With a bus clock of up to 200 MHz and a data rate of up to 400 megatransfers per second, DDR1 represented a major leap over older SD-RAM. A DDR1 module could reach a maximum of 1 GB per stick and operated at a voltage of 2.5 volts, which made it fast for its time, but also relatively inefficient in terms of power consumption. DDR2 was released in 2003 and brought higher frequencies and lower power consumption. For desktop systems, DDR2 modules use 240 pins, while laptop modules use 200 pins. With a bus clock of up to 533 MHz and a data rate of up to 1066 megatransfers per second, DDR2 practically doubled the maximum speed compared to DDR1. The maximum capacity reached 4 GB per stick, and the operating voltage dropped to 1.8 volts, reducing both power consumption and operating temperature. DDR3 was released in 2007 and represented a major step forward for modern RAM. Is the generation in which dual-channel memory became standard for most consumer systems. With a bus clock of up to 1066 MHz and a data rate of up to 2133 megatransfers per second, DDR3 delivered a significant performance improvement. For desktop systems, DDR3 modules use 240 pins, while laptop modules use 204 pins. The maximum capacity reached 16 GB per stick, and the operating voltage was reduced to 1.5 volts, helping lower power consumption and improve battery life on laptops. DDR4 appeared at a time when DDR3 was already extremely mature and fast enough for most users. However, DDR4 was specifically designed for the next generation of multi-core processors. With a bus clock of up to 1600 MHz and a data rate of up to 3200 megatransfers per second, DDR4 focused not only on raw speed, but also on much more efficient memory usage in modern applications. The maximum capacity reached 64 GB per stick, and the operating voltage was reduced to 1.2 volts. For desktop systems, DDR4 modules use 288 pins, while for laptops uses 260 pins. With the rise of modern multi-core processors, especially on the AMD Ryzen platform, DDR4 became the preferred memory generation for gaming, video editing, and multitasking. DDR5 was introduced in the year 2020 and changed the internal architecture of system memory. With a bus clock of up to 3200 MHz and a data rate of up to 6400 megatransfers per second, DDR5 is the fastest memory generation currently available for mainstream consumer systems. For consumer desktops, the maximum capacity goes up to 64 GB per stick, while the operating voltage was reduced to 1.1 volts. For desktop systems, DDR5 modules use 288 pins, and for laptops, they use 262 pins. In addition, each module is split into two independent 32-bit subchannels and includes features such as on-die ECC and on-module power management. For DDR6, the industry expects the first commercial platforms around 2027, with an estimated base speed of approximately 12,800 megatransfers per second. As you've seen, megahertz represents the actual operating frequency of the memory, while megatransfers per second represents the effective data transfer rate. With older SD-RAM memory, the frequency and the data rate were the same because data was transferred only once per clock cycle. And, as mentioned earlier in the video, with the introduction of DDR memory, data is transferred on both the rising and the falling edge of the clock signal, which effectively doubles the data rate. So when you see a memory kit advertised at 6000 MHz, it is actually running at a real clock frequency of around 3000 MHz. In this video, we only show the standard speeds for each memory generation. Faster memory kits do exist, but they rely on overclocking profiles and usually higher voltage, and are not part of the official standard. If you enjoyed this kind of video, make sure to subscribe to our channel, and if you give us a like and leave a comment, it really helps us out. Thank you.